I don't have anything. Welcome back, everybody. Today, we're going to start looking really briefly, or really quickly, rather, at 5.5.1. Now, for this, we're going to be looking at function operations. And the cool thing is, you guys have seen every single operation that we're going to do, almost every single operation that we're going to do today throughout your careers. And I think that your intuition for them is probably going to be okay. So we're going to start with our warm-up, just to make sure that we're like on the same page. And you guys will be taking the following problems up to the board. Okay, I'm going to give you two functions. And let's say that f of x is the lovely function, I don't know, x squared plus 2. Okay, beyond f of x being x squared plus 2, I also have g of x, which we'll say is 3x minus 4. Okay, two different functions, f and g. We're not going to graph these, but I am going to check. Zed, we made eye contact. What does the graph of the red one look like? Just like this? Are you sure that x squared will look like that? Hey, it's a parabola, and it's upward parabola. Okay. What about the green one? It's a straight line, right? It's a linear function. mx plus b is a form that I see. Okay, here is your challenge, and you're going to be evaluating all four of these, and let's check it out. A, I want you to do the following. F plus g of x. And I'm not going to give you anything else. I just want to see what do you come up with. On B, we're going to do f minus g of x. On C, and I'm going to leave like barely any space here. You guys will have space on the board. On C, let's switch flavors here. We've done two pretty basic operations. Is there another fairly basic operation? Hey, let's do f. And then this is going to be weird, but I do not want you to put a dot. I don't want you to put a time symbol. We're just going to write them next to each other like this, indicating that they're multiplying. F times g of x. And there's one more operation that we're after. Hey, it's division. Okay, on D for division, that worked out nicely. I want you guys to, I want to see what you come up with for f over g of x. Now, I've given you nothing additional other than the fact that you guys know how to add, multiply, subtract, and divide normal numbers. The only hint that I'm going to give is on delta. I do not want you long dividing. I don't want you synthetically dividing. I just want you to try to clean it up. Show me what you think that this is telling us to do. Cool. No further explanation. Let's hit it out. We got 26 in here, which is not a super nice number. I like groups of 3. Groups of 4 might be too big. Let's see. 1, 2, 3, 4, 5, 6. Indeed. We can fit 2 groups here, right? On each of these boards. Okay. Do you guys have these problems written down? So if I turn off this board, you can still see the problems. Okay. Check it out. We're going to go straight. We're going to snake through like this. So we're going to go 6 groups. And then the last, is that right? 6 groups? Yeah, 6 times 4. No, you'll be okay. Like, we'll see if we get it. Awesome. If we don't. Anyway, 1. Nope. 4, 5, 6.
2, 3, 4, 5, 6.
Okay, so everybody has a number 1 through 6. I want 1s up here. 2s, you will work here. 3s, I'll turn this board off. 4s, 5s, 6 will be behind Miss Sweet. And I'm going to pull 2 people from groups here. And we're going to get one more group that's going to work on a whiteboard at your table. Or you can stand up if you want. But, oh, wait, never mind. I'll go fill it up for you here in a second. I got you. All right, 5, 6. Cool. 1, 2, 3, 4. 5, and 6 back here on the back wall. You're a 6, Kyle? You're 1? Okay. All right. So, real quickly, can you guys line up single file? Just I'm going to pick people from groups that are too big. You're a group of 4? 5. Chetty, you're drafted. Who's in this group? This is not single file at all. Is it you 5? Okay. Michaela, you've been drafted. You're 4. You're 4. You're 4. You guys can use this board over here. Do I want one more from here? All right. If I tap you and have you move groups here in a second, I'm cool with that. 5 minutes, no additional guidance. I want to see, what do you guys think happens with these? 5 minutes, starting right meow. Here's a marker for you. I'm so sorry. Yo. Okay. And I actually have one in my pocket if you can catch. Yes, will you take the box up there? Yes, I will, Lando, because I just want to mute it. Cool. Will you pause on the very top of the screen, there's a pause button. We just hit that. All right. As I'm looking around the room, I'm seeing some awesome stuff happening. And you guys have shown that the first half of this lesson is essentially done. Now, when we read this, I had a couple groups having a mistake here. I had somebody ask me, and I had 2 different groups, just so you guys know, saying, what's up with this random X floating around? And then I know that I didn't stress, like, hey, I need everybody to listen like as clearly as you can. My hope is that that's kind of the standard in here. But when I read this one, I did not say F plus G X. There's a word that I just forgot to say. F plus G of X. Now, as we look at this, looking around without any justification, what I see is this group, x squared plus 3x minus 2, x squared plus 3x plus 6, minus 2, and we're just checking them all, minus 2, and back here we have a minus 2. If we look at any of these groups work, how did you guys start to expand this? We just plugged it in. What do you mean you plugged it in? Can you be more specific? Okay, I agree completely, but I'm going to change the language just a little bit. If you did not hear Perscovia, she said, we just did x squared plus 2 plus 3x minus 4. Now, if we look at this, and it's not multiplication, but if we kind of treat it like it is, that x wants to distribute, right? If we distribute it, instead of me saying we distribute an x, if I said it's like we're distributing an of x, which is a weird thing to say, but I think it's what I see all of you doing. In here, when we do this, this is not just f anymore, it's f what? Of x. This is not g anymore, this is g of x. So what we're going to do with these is, I'm not going to work all 4 of these. I don't think we need to. Instead, what I want to do, because I can see that your groups, with the exception of, this is a weird one, with the exception of D, you guys, without any guidance, did exactly what I was hoping you would do. If you got to write the rules of math, or if we were writing it and I gave you this, you guys showed me that, yes, you understand what is being asked of you. So let's just sort out these properties here. In this, it's going to be weird in our notes because this is our warm-up, and we're not going to have the answers here unless you want them. But what we're going to make out of these is all of our properties of function arithmetic. Okay, now we are generalizing, and we're going to generalize. And I've already heard a couple groups do it. Perscovia, I loved your answer on this one. If we have f plus g of x, when we go to actually evaluate this and we quote unquote distribute the of x, what did this give me? What am I actually doing here? So you're right, but be less, I don't need the specific, what is that function called? F of x plus g of x. This is our property. And you guys did exactly what we should do. This one oftentimes trips people up, and I kind of hate the place that I put this, but we'll just do it here. I'll just put equals here. Is that okay? I hate it, but you guys have probably already written this here, so I'll adjust with it. What do you think happens when I do f minus g of x? F is for Fred. What do you think happens here? Nope, this is Fred. If this one just distributed the of x, what do you think this is going to do? Good. What would you have me write then, Fred? So good, but instead of x squared plus 2, do we have a name for that function? What did we call this function? So if you said, hey, Holloway, graph a function, you could give me this whole thing, or you could just say, it's, what function is it on the other side of this equal sign? The question's weird, and I can't figure out why. Anybody know what I'm asking and see where I'm asking it in a weird way? Okay, lots of feedback here. Deal. Fred, do you agree that we call that first function f? Okay, that's all I'm after. Like, it's a weird question. Sorry about that. So when we distribute, instead of, you were right, x squared plus 2, but could I just say that's f of x? And then what do I do? Oh, okay, I minus or subtract g of x. Now, I want to highlight how psyched I am about this, because this is always the place that historically I've seen groups make mistakes. Whoever this was, if we look at B, I love what you've done. And whoever this was, love what you've done when you subtracted. Whoever this is, love what you've done. You didn't show it, but I love it. Love it. Okay, what I see every group in here doing, which is the most common place to make a mistake, is when you put in g of x, when you did minus g of x, what did every group essentially do? They put parentheses around it to ensure they distributed the negative, because you have to distribute the negative. That is the most common mistake. You guys avoided it. Kudos for that. Okay, looking at this, if you need a warning, question, hold on, somebody asked. Somebody said, where do we distribute it? I don't know who it was. Don't care who it is. Can you ask that question again? Okay, no question? Deal. All right, go out on a limb here. What's going to happen when we do f times g of x? F of x times g of x. And then now I imagine the trend is starting to show up. For the last one, what's your gut say we should write? F of x over g of x. Now, we jump into rational function land at this point. Is there anything that we have to be worried about when I have a function in the denominator? So radicals I certainly worry about, but I don't have any radicals in this. There's no square roots or cube roots or anything. Lando?
For the letter C, could you just also do f of x without the dot?
You could do it without the dot. Yep. And then like here, I'm okay with the dot. You could just put parentheses or brackets around them. Good question. Okay, this one. What can't, like, I'm trying dividing, right? Yeah, Ronaldo, what am I worried about the denominator being? 0. Why do I worry about the denominator being 0? We can't divide by 0. That's against the rules. So I'm going to put a little caveat, one small additional comment in here, where we're just going to simply state that no matter what's down here, we require that g of x, whatever it is, cannot be equal to what? 0. Okay, these are the 4 arithmetic properties for functions. Easy. If you got to write the rules and somebody said, hey, what do you want this to do? This is seemingly the natural choice for you guys. What questions do we have about these before we move on to much more fun operations? So, do you want to look at this one division here? Yeah, let's do it. And you guys are going to look at this and be like, okay, that's what? And it's easier than you think. So let's try it. If I'm doing this one, and I would encourage, if you want the examples in here, include them, but it's not required because you guys showed me that you're going to do what is expected anyway. So check it out. What was F? Over, what was G? Now I'm going to do just a small little amount of scratch work here. My scratch work that goes into this, and some of you can do it in your head, and that's okay. I simply require that 3x minus 4 cannot be equal to what? 0. Now, this is always a weird decision. I don't mind solving the not equal to, and I can't even call it an equation. I would call it a not equation. If we treat this like it's a regular equal and just keep it not equal so we don't have to change it at the end, and I want to get x alone, what do? Add 4. Is there another step that we can see happening? So we said x cannot be equal to 4 over 3. Because if I make x 4 over 3, the denominator is what? 0. For anybody out there, anybody look at that and go, how the hell did you get 4 over 3, Holloway? Okay, check it out. If I want to solve for x, and it's, again, weird language, but I'm going to keep the not equal to, I'm going to add 4 to each side. And I would then decide that 3x cannot be equal to 4. Are we still cool there? Last step, if I want to get x alone. Yeah, now we'll divide both sides of this by 3. And all of a sudden, and I can see it's going to happen here, we'll say x cannot be equal to 4/3. And then all that I'll do is I'll come over here, and on this, I'll just simply say, okay, x cannot be equal to 4/3. When we make that comment, and I'm telling you, there's an x value that you can't pick. Is there a bigger collection of x values that we do choose to plug into our function? What do we call all the x's that we plug into our function? A single word that encompasses every single possible input. So if it were every number, I might say this is all real numbers, but it's not all reals, and I can see there's a real number that doesn't work. There's a D word that I'm looking for, the domain. Without being really explicit about it, and I guess I am now, this is answering the question regarding our domain right now. Okay, every x value except this is okay, is what we wind up getting. Cool. Okay, these operations, you will get practice with them. My best suggestion when you're doing these is if this is where it starts, my first line is going to be to write this. Like straight up f of x plus g of x. I will do this every time. I would encourage you to do this every time. Cool, cool? Like for this one, yes. For the division, this is the answer. And I know it's unsettling because it looks like, oh, we should divide it. We're not. We're just saying, hey, here's a bigger function that's now just this divided by this. Okay. Can you guys think of a situation where this might like apply? Anybody into economics in here? If supply goes up, what happens with demand? It goes down. And you might consider that ratio against one another, right? Like if you're a business, you want to know what's the supply, what's the demand. Do you think that like billion-dollar businesses have mathematicians on staff or engineers, whoever it might be, that say, here's a function that we've said determines your demand? Like for sure, right? They're going to have that. Are they going to have somebody that determines a function for the supply? You don't think that they're worried about how much stock they have in inventory? Like they have to, right? Like they have to know how many units do we have to sell, because if I think I'm going to sell 10,000, why would I waste money making 1 million, right? Like I need to know how much people are going to want. If I wanted a metric, a way to measure like, hey, are we doing well as a business? Are we like more people buying it? I might check the demand over the supply and see what that ratio comes out as, which if I have a function for each of them, that is a perfect candidate for this sort of situation. Okay, beyond these, the 4 basics, nothing too crazy. We'll get practice with them. We're going to jump into a much more fun operation that I don't think you guys have seen. Okay, today, we won't finish it today, but we'll get at least the underpinnings. We're going to be talking about the composition of functions. Do you guys know what a composer is? So can you name any? Beethoven. And Beethoven was a composer. Okay. What does it mean when he composes? Like, what does that mean if I said, oh, Beethoven spent all last year composing this piece of music? He's what? So he might be the person up on stage, like leading it. Did he actually write the music, you think? Beethoven did, for sure. So he's like, when we talk about composing it, go ahead. Are you looking for this notebook, I assume? All right, you know you can say that, right? Don't say never mind. Okay. To compose a piece of music, do you agree that it's Beethoven, and I don't know his actual process, but is he just putting a bunch of different pieces together? Like, that's what it means to compose something. Let's put stuff together, see what it's made of. That's what composition means. Like, what's the composition of a material? That's a chemistry question, but you might tell me all the different ingredients, the things it's made of. So when we talk about this composition of functions, we're going to hold off on just a second for a real formal definition. Do you guys ever remember using mappings to talk about functions? And what I mean by that, and we'll decide if we're going to go this route. So pink is think. Do you guys ever remember having something with me or Jarvis where you have domain, and I guess it could have been with Osmond, and a range? And I can even back up a little bit. Maybe I have 1, 2, and 3, and I have over here 4 and 5. Do you guys ever remember thinking about functions like this? Okay, so all that's happening here is we have a domain where when I plug in an x into this function, what does it spit out at me according to this picture, Kennedy? 4 specifically, but it's my range. Like a function just takes stuff from the domain to the range. Now we can think of it a million different ways. It's a machine, right? We plug in an input and it gives me an output. It's the same language. Domain goes to range. And normally what does this is a function, something like f. Now, we're going to use this idea, and it's not going to be the most fundamental part of it. It's just the intuition part of it. If we start here, let's say that I had a function, and we're going to do some specific labeling. I'm going to call this the domain of a function that we call g. Okay, and I can put numbers and stuff in here if you want, if we need them. But whatever's in the domain of g, it's going to move to the what? So careful. Why would it switch functions here? The range of g. So for example, I'm just going to do 1 here. We might have x goes in, and then f of g, sorry, g of x rather, my bad. G of x is the output. Comfortable with that? And whether you've done like hardcore with this or not, I'm not sure. But I'll just say this is function g. Now, is it conceivable that I plug in I'm just going to make up numbers, don't write the pink. Maybe I plug in a 2 and it spits out a 3. Is it now possible that I want to plug 3 into a different function? Like maybe there's a reason, and we don't see it yet, but if I say that this gives me 3, and now I need to see if I plug 3 into the second function, what does it do? Well, let's just consider that. If we had another function mapping from whatever this was to here, it would be, we're going to call it f. And this is where things get wonky for just a second. We have 30 seconds left. We're going to start doing problems like this tomorrow, but we're going to finish this first. If I forget about everything else right now, and I don't want you to erase, but let's say this is all I had and pretend the box is still there. This would be the what of f, if it's what I'm plugging in. So careful. Get g out of your head. Is this a domain of f or the range of f? Of f. So now I'm going to have another function f that goes from here to here. Do we all agree that this is what's going to plug into f, and this is now the domain of that function? So today, the last thing that you need to write, and I know it's weird, this collection is the range of g. But if we're going to plug it into f, then we can think about it as the domain of f as well. There's one more box that we go into here. Whatever I plug in, the domain of f, it's going to spit out the range of which function? The range of f. Okay. It would be tedious to do 2 functions every time, right? Tomorrow, we're going to make it not 2 functions every time, and we're going to see how it connects. There is no assignment this evening. Enjoy it. If you want test or quiz improvement, remember, this is your last opportunity for doing this. Come talk to me at lunch. I will print one out for you for study hall today. It might be in here. I lied. I'll be in here. I'm going to proctor them. Cool. It's a different version. Later, Raiders.